let's explore another interesting situation that involves collisions. This time, we have an inclined plane 1 which makes an angle 60 degrees with the horizontal. And there is a particle of mass m falling from a height h above the base of this inclined plane, and it reaches this point. This is the separation between two inclined planes, inclined plane 1 and this is inclined plane 2. This is commencement of inclined plane 2, which now makes an angle 30 degrees with the horizontal. I'll assume everything is smooth here, right? Now, first part of the problem, where they say if on passing from 1 to 2, see, which is actually collision, and passing from 1 to 2, if the coefficient of restitution of this collision as this particle migrates to 2 is 0, we want to find the velocity of the ball just after leaving plane 1, that is just when it enters plane 2. This is what we want to be able to do. That's the first part of the problem. Let me deal with the first part of the problem first. So one thing, when the particle goes from this to this point at the interface, it acquires a velocity v0, and as you already know that this v0 from a height h, if there is no friction, is going to be root 2 gh, right? Now, why would you think this is collision? Yes, indeed it is collision, because see, if I look at plane 2, this is plane 1, right? This is plane 2, this is plane 1, and if I just extrapolate plane 1, then this particle is coming to this interface, which is this point, with a velocity v0. So would you not think it's a case of oblique collision? This particle of mass m hitting plane 2 with a velocity v0 as shown, right? So it's oblique collision, right? Now, there is a normal to plane 2, which is this line, and this is parallel to plane 2. This velocity v0 could have been resolved as you can see again, you know, this angle is 30 degrees, alternate angles 30 degrees, this is 60, this whole thing is 60, so this is 30. You should be able to figure that out independently. So this v0 could have been resolved as v0 cos 30 degrees like this, parallel to the plane, and v0 sine 30 degrees perpendicular to the plane. And what happens if a particle hits perpendicular to the plane and E is the coefficient of restitution? Then, if it hits perpendicular to the plane, perpendicular to plane 2 with a velocity v0 sine 30 degrees, which is v0 by 2, then in this direction, its velocity of rebounds is going to be E v0 times E v0 by 2, right? But E is 0, so this becomes 0. That means when it transits to plane 2, because of E being 0, its velocity perpendicular to the plane becomes 0. Its relative velocity of separation perpendicular to the plane must be 0. It therefore just moves along the plane with a velocity v0 cos 30 degrees. So when it migrates into plane 2, right after this impact, then its velocity simply becomes v0 cos 30 degrees, where v0 we know is root 2 gh, and cos 30 degrees is root 3 by 2. That is its velocity, v0 cos 30 degrees. Yes or no? So which is like root 3 gh by 2 is its velocity, which is parallel to the plane evidently, right? Now, so that's the first part of the problem. I hope you understand why it's a case of collision. This is an oblique collision with plane 2 while this particle comes to this interface. The second part of the problem, if the particle moves horizontally just after collision, find E. Alright. So now what happens? E is not 0. Second part of the problem, it's some other E. So its velocity perpendicular to the plane, its velocity perpendicular to the plane 2 is going to be E v0 by 2. Its velocity parallel to the plane, and you know all these angles. Let me put all these angles in perspective. Right? This is this is the inclined plane. This is the inclined plane. This is this line. This is the horizontal line. This angle is 30 degrees. This angle is 60 degrees. Right? Now, this is a line parallel to the plane. This is perpendicular to the plane where the impact is supposed to occur. Right? Now, parallel to the plane, its velocity will remain v0 cos 30 degrees. Yes or no? Post collision, because there is no friction. component of velocity parallel or that in the tangential direction will not change. However, its velocity in this direction will become EV naught by 2. Yes or no? Which, if this is 30 degrees, this is 60 degrees, right? This is how it is. Now, if the velocity becomes purely horizontal, that means this V naught cos 30 degrees, this V naught cos 30 degrees, and this EV naught by 2, this EV naught by 2 and this V naught cos 30 degrees must have a resultant which is horizontal. That's when its net velocity would be horizontal, right? Which means their vertical components must cancel off. See, this is 60 degrees, this is 60, this must be 30 degrees. If this is 30, this is 60, this is 60 degrees. That means for the net velocity to be horizontal, the vertical components must cancel off. Vertical components are like a EV naught by 2 cos 30 degrees must be taken care of with V naught cos 30 degrees, V naught cos 30 degrees. This velocity V naught cos 30 degrees, its component in the downward direction is into cos 60 degrees. Yes or no? I hope you realize that. Component of this in this direction must be the same as component of this in this direction, so that in the vertical direction it has no velocity. Its velocity will then be purely in the horizontal direction. And what would this give me? Realize that cos 30 degrees gets cancelled. Cos 60 is half, so this will get cancelled. V naught will get cancelled. That will give me E equal to 1. Yes or no? So this was another interesting, not a difficult situation, but an interesting situation. It'll give you a world of wisdom, but we'll look into more problems and have some more fun with collisions and center of mass. This much for this problem. Thank you. Bye-bye.